Hello, algebra students. Welcome back to a new video lesson as we start chapter 9 and begin to look at quadratic functions. And so in today's video, we're going to focus on comparing and contrasting different graphs of quadratic functions and exploring the graph and characteristics of y equals ax squared plus c. And so we're really kind of just expanding a little bit on your exploration from yesterday and trying to see what did you notice and how can we use that information to help us create some of these graphs. And so I'm working a lot out of your packet, the chapter 9 packet, which was shared yesterday. And on page number 2, we had two different graphs, y equals x squared, y equals negative x squared. And you were asked to create a table of values. And from that table of values, you were then asked to try and graph. And so I'm just kind of sharing with you my answers from that page 2. You might want to just double check to make sure you have the same thing. But the biggest note, and we discussed this in our live sessions, is to notice that one of them has positive x squared and the other one is a negative x squared. Which means we're really, like if I'm trying to plug in negative 2, I'm taking the opposite of negative 2 squared. Negative 2 squared is a positive 4, so this piece gives us positive 4, but we were taking the opposite of that, right? Whereas over here, it's negative 2 squared, which is positive 4. And they don't have that negative sign in front. And what that does is it causes this graph to have a different look to it, right? One of them, the graph will look like this, which is a typical U-shaped, and the other one is an upside down U for the graph here. And so pay close attention to maybe why that is happening. All right, so the graphs at number 8 and 9, right? These two graphs, they're curved. They're not straight lines, right? So they're curves. And I'm hoping you maybe remember what the name of those are, right? What'd you put for letter B? Well, these are called parabolas. Looks like parabola, but it's pronounced parabola. And really, the name to the equation is called quadratic. These are called quadratic equations. And this is what we were working with in last chapter, was a lot of quadratics. But anytime we have an x squared component, it's called a parabola or a quadratic. All right. At one point, the graph switches from increasing to decreasing or from decreasing to decreasing, right? Oops, wrong way. And so you'll notice here it goes decreasing until we get down to here, and then all of a sudden it switches back to increasing. Or this graph, it's increasing, and then all of a sudden it switches to decreasing. All right, and there is a special name for that, right? What is that name of that point? The name of the point where that happens? That is called the vertex. It's that point where the graph switches from increasing to decreasing and back to decreasing, right? And in both of these, that point was going to be 0, 0. Okay, so that point was 0, 0, and we call that the vertex of the graph, the center, if you will, where it changes. Now, we also have what's called a line of symmetry. Each of these quadratics will have a line of symmetry, and that means that if I were to draw a line in here, that both sides of this graph act the same. They both are increasing on this side. They're both increasing on that side. You know, same thing on this one over here where it's upside down, where it's decreasing on both sides. And if I, plot a point at 9, it's 3 away. It's also 3 away to the other side. That's that line of symmetry. And what you'll notice is the line of symmetry has to go through, it goes through the vertex. Through the vertex, which means its equation is going to be x equals wherever that vertex is. Well, in both of those, the x coordinate was 0, so we say our equation for the axis of symmetry or the symmetry line is x equals 0. Okay, and so those are a couple properties of what's happening here and some more specific definitions. I would make sure that you pause and you get these down here on page number 2. All right, now what I want to try and see is how did you do on page number 3, number 11? I'm hoping that you tried this one. And you could go to Desmos. The beauty is that we could always go to Desmos and graph some of these. All right, and so what I did over here in Desmos is I graphed the first two. Y equals x squared, which I did in red. Y equals negative x squared, which I did in blue. So now if I type y equals 3x squared, so doing it in green, and you'll notice that it opens what we call opens up. All right, so we're going to say that it opens up. Where's the vertex? Well, the vertex is still here in that exact same spot. Right here's the bottom of it, still at 0, 0. Therefore, what's the equation of that symmetry line? X equals 0. What is the y-intercept? Where does this green line touch the y-axis? Y equals 0. So the y-intercept at 0. Well, what happens if we graph y equals negative 3x squared? Y equals negative 3x to the second. Now, it's this purple one. It's opening down. But notice, everything else about the graph stays the exact same. The vertex is at 0, 0. The symmetry line goes through 0, 0. And the y-intercept is at 0, 0. Right? The only thing that changed was it opened down. Everything else about this graph stayed the same. Vertex at 0, 0. Equation for our line of symmetry is x equals 0. Y-intercept is 0. And therefore, I'm hoping we can make a conclusion about what happens with this number that is out front, this a value. Okay, so whenever we refer to the a value, we're talking about the number directly in front of the x squared, 3x squared, or negative 3x squared. Okay, what does that number do? Well, one of the things that it does is it tells us if the parabola opens up or down. If that a value was positive, we got a graph that looked like a capital U. The parabola opened up. If the a value was negative, like negative 3x squared, it would open down. So that's one thing the a value tells us. The second piece that it tells us is whether or not the graph gets wider or narrower. Okay. Now, we haven't done one yet where the a value is less than 1. But we have done it where the a value is greater than 1, right? A value greater than 1, y equals 3x squared. That's greater than 1. What happened to the green? It got narrower or closer together. It's inside the red. It's inside the regular y equals x squared. And so it makes it narrower if the number gets higher. The numbers are all going to jump up much faster. Okay, so that's the big thing with the a value. Up and down, narrower or wider. All right, so we can test this inside of Desmos. All right, and I'm going to use these three, y equals x squared, 3x squared, 5x squared. I'm going to get rid of our negative ones for a second. X squared, 3x squared, and y equals 5x squared. And look how that black line for this one gets even closer together and inside the green. All right, and so the conclusion here is that even though we're adding nothing to the end, right? I could add a plus 0. It doesn't change anything to all of these. The vertex stays right there at 0, 0. But what's happening is it gets closer and closer together. Same thing if I put a negative sign out in front, right? They're going to get narrower, as we call it. Even if I put a negative sign out in front of all of those, what is the only thing the negative sign is going to do to all three of those graphs? Hopefully you understand that all it's going to do is flip them upside down. See? Change them all to negatives and just flips them so that they are opening down. Okay? And they're still going to get narrower. Right? Those numbers are still, larger than 1, so to speak. They're getting higher. And so as that a value gets further and further away from 0, the parabola gets narrower and narrower. All right. Now, what happens, though, if we change it, right? So far, we've only been working with this. Y equals ax squared plus nothing. We didn't have any other number out here. Now, what we're going to do is add something called a c value. This c value. Okay. So I'm going to graph these two over here on Desmos. Y equals 2x squared. There's my first one. And then it wanted me to subtract 10. Pay very close attention. 2x squared. If I could type minus 10. Whoa, it even went off my charts a little bit. What happened to the blue graph? It went down 10 units. The vertex is not at 0, 0 anymore. The vertex went down here to 0, negative 10. It's the same function, 2x squared and 2x squared, so it opens up because it still looks the same, but it shifted the vertex down. Parabola here, 2x squared is up, and so is this one because the a value is still positive. Vertex is 0, 0 on the original one, but now, as we said, the blue moved down to 0 to negative 10. So the vertex shifted down. What is the equation for the line of symmetry? Well, it's still going to be the exact same line. It still goes through the middle. So that's still going to be x equals 0 for both. However, what's the y-intercept? 2x squared. Where does the red one touch the y-axis? Right there. So it's still 0, 0. But where does the blue one touch the y-axis? Where is its y-intercept? At negative 10. So y equals 0 for the standard one, or y equals negative 10 when we changed that c value out on the end. So what I want you to be able to do, though, is make a conjecture or a hypothesis or a conclusion. Pause the video for a second and tell me, what do you think happens when we add or subtract a value from y equals ax squared? What do you think happens if I have ax squared plus c? Or what do you think happens if I have y equals ax squared minus c? What happens? Well, hopefully you can see from those two graphs that if I subtracted 10, the vertex moved down 10 units. The vertex moved, the y-intercept moved. What happens if I do the same one? Y equals 2x squared, but let's add 5. It's in green. Well, what happened to the one from 5? It went up 5 units. So the conclusion here is that when we add c, the vertex moves up. By c units. Whatever that c number is, the vertex moves up, which also causes the y-intercept to change. Down here, the vertex moves down by c units. It will go down. And we can use this information to describe then what is happening to certain graphs. All right. How do these two compare? Well, one opens up and one opens down. This one is wider because it's closer to 1, where this one is narrower because it's further away from 1. So positive, negative tells us opening up or down. Closer to 1 is wider. Farther away from 1 is narrower. And then that c value, as we had just described, the c tells us to move the vertex up or down. So take a minute to summarize, and if you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.